thank you very much. I appreciate Sharon and the team letting me come back to Israel and to be able to talk to you and to kick this off. I'm very big on the fundamentals. I like to keep the most important things the most important. And so I wanted to talk a little bit about engineering with passion and purpose, and to share uniquely with you guys the things that are important to me and the things that I've learned particularly from the Israeli people and from Judaism, and some of the things that are uniquely important to me and I kind of don't really get a chance to share anywhere else in the world. I am the VP of Site Engineering over at Packet. Packet is a company that does bare metal cloud. If you guys do anything in the data center, if you've ever had to stand up a data center to do any kind of work, you'll know that it's a real pain. What we're all about is trying to lessen that pain by giving you an API that can manage the servers, the network, the PDUs, all that terrible infrastructure stuff that's awful, so that you can just get to building the things that you want to build on the infrastructure as quickly as possible. But before I was there at Packet, I was the director of operations over at Chef Software for a while. Does anybody use Chef? A couple of people. Everyone uses Ansible now, right? No. Right? No? Okay, good. Yes, Chef. Stick with Chef. Before that, I was the director of cloud operations at Joyent. I started at Joyent in 2005, 2006 when we started out, which is a really interesting time because there was no such thing as cloud at the time. We were trying to make a better hosting solution than what was available at the time by giving people direct access to infrastructure, and it eventually became cloud. So I got to be the fun guy who spent like 3 years just going around and trying to explain to people, what is cloud? Prior to that, I was at a smaller company called Homestead back in the days when online photos were a thing and small websites was a thing. And prior to that, I was in the Silicon Valley doing a lot of systems engineering sorts of things on mid-range systems. Sort of the point of my past is that change happens. I put on here a couple of technologies that I used to be an expert in, used to be really important, that are now completely and totally irrelevant. It's a fun thing about what we do is change is happening all the time. And in technology, I have what's called I like to call the problem of the fast and the slow. This industry moves really, really quickly. On the other hand, it really doesn't move that quickly at all. And what I mean by that is that if you look at it, new technology is coming all the time, right? Just think about what's the right programming language to be using. It seems to be changing all the time. But the reality is if you look at it on average, it takes about 10 years for technology to go from a new concept to accepted, generally accepted in the industry. And you guys are maybe familiar with crossing the chasm and the idea that there's sort of early adopters, sort of mid-range, and then sort of late adopters. That whole cycle takes about 10 years. So if you look at some of the dates I put on here for some of the technologies around, Ruby on Rails showed up in 2003. MySpace, does anybody remember MySpace? That was a thing in 2003. Facebook came along only a year later in 2004. Twitter, 2006. AWS, 2006. DevOps became a thing, 2008. Docker started out in 2008. Go became a thing and burst onto the scene in 2009. OpenStack, 2010. AppsFlyer, according to Wikipedia, you guys all got started in 2011. Is that accurate? Because I keep hearing 2.5 years. Kubernetes, 2014. So if you think about a bunch of those technologies, think about where we are in the sort of life cycle of a bunch of those technologies, right? When it comes to MySpace, gone. Just completely gone. It came and it went. When you look at Rails, very mature, kind of not normally where you want to be, but there's still a lot of it that's out there today. Twitter, still growing, but it sort of hit that peak, right? AWS, definitely a thing. AWS is an interesting one because in its first sort of 4 or 5 years, it was very dangerous to go running on AWS. Now, you generally need to explain why you're not on AWS if you aren't, right? Very big change in terms of adoption there. DevOps, 2018, in 2008, it burst onto the scene. Now when we look at DevOps, we're kind of almost post-DevOps now, right? It was a thing, it served its purpose, and now we're well beyond it. We're looking to sort of what comes next. Docker is definitely an interesting sort of story. We're now 11 years into Docker. Docker, of course, is probably the least interesting thing in the whole container space now, right? We're all sort of post-Docker now. But containerization is here and here to stay. Go's really hit its stride, finally, right? And we're now 10 years in to Go. So it's really interesting when you look at things are changing all the time, yet at the same time, it takes quite a long time for things to get to a point where they're generally accepted. So, systems. Systems are what we're all about, right? Fundamentally what we're all about. I'm a big proponent of systems thinking, and it's something that a lot of us haven't been properly trained in, I don't think, but it's something that's really important to me. A system, fundamentally, is comprised of components which interact to create emergent properties. And the important thing there is that no single part of a system contains those properties themselves. The interaction of those parts is what produces the value that we want to provide. And so when you look at a system, there's sort of two ways to approach a system. One way of addressing system is through analysis. That's where we take a system and we break it down into its components. We take those components apart, we see what they do, understand them, put them back together. That's what children do, that's what we do. That's the most fundamental way of understanding any sort of system. But in order to really understand a system, we have to actually engage in synthesis, which is not just taking the components apart, but putting them back together and seeing how they interact together and with other systems around it. And that process is called synthesis. This is a higher level thinking. If you think about architecture, when you do architecture of a system, you're not just looking at the individual components, you're looking at how that system emerges properties and how those properties interact with other systems around it. All systems interact with other systems. And so an important part, I think, of what y'all are doing this week with Hackweek is that as you're building projects, we all have to remember that you, humans, are a part of every system that we build and every system that we operate. That's humans in terms of customers that are actually using your applications, either the end user using the AppsFlyer, other engineers within the organization who are consuming projects that you use or interacting with projects that you use, or you and actually taking care of your daily work. Every system must consider the human element and the humans that are part of that system and how they interact with that system. And I think this is a fundamental difference in projects that are really successful and projects that really aren't. Those that focus on humans and what humans need in terms of the value that they need out of the system and the properties out of the system are going to be the more successful ones. And we've seen this sort of come out in a lot of ways, right? We used to build big monoliths. Now we focused on building microservices, right? Those services can be decomposed in such a way that it's easier for individual teams to work with them. And then we are focusing on the interactions between those services to actually produce emergent properties. And it's interesting when we look at the way that as an industry we're looking at services and decomposition is really trying to figure out what's the right amount of granularity. So one of the best examples of a system actually is us, our human bodies. We have emergent properties, but none of our individual parts necessarily produce the actual sort of output, right? So what is our essential nature? It's life, that we're alive. But no one of our parts is necessarily alive. It is a combination of all those parts, right? Fun experiment to do, cut off your hand, put it on a table and see what it does. It doesn't tend to do much of anything, right? Your hand doesn't have life, you as a whole have life. And so we're always looking at the interaction between all of our components in a system, how they interact, and what the emergent sort of properties of those are, and what we actually want to derive from that system in terms of value. So Hebrew is a much better language than English. English is a terrible language. I love Hebrew because there's a precision and a depth in the language that is intrinsically useful, and that really makes me appreciate it. And I think the keys to success in engineering tend to come down to two words I think that are better captured in Hebrew than they are in English. And that's Kavanagh and Avaha. So let's talk about love first. Love, right? We all love what we do, right? We love our users. I like the Hebrew word because literally this means give, to give. And in tech, we put a real premium on contribution, right? We all are expected to be giving. The more successful we are in engineering, the more we're giving. We've seen this particularly with the open source explosion, right? We all want to be contributing and giving back. In knowledge work in particular, right, it's really about bringing our whole selves. When you guys were hired on to AppsFlyer, you weren't just hired because you happen to know this skill or that skill, right? You were brought in because of the fact that you had the ability to learn, you had the ability to grow, you had skills that enabled that, and that you could apply those to problems that you wanted to solve. We're all expected to come to work with our whole selves and to give and contribute what it is that we have uniquely to give to the team. In technology, our prime asset is that ability to learn and to grow. Constantly assessing, looking at sort of the situations before us and applying technologies to what it is we want to do. And so when you think about giving and you think about humans and the needs that we have, you guys have seen Maslow's Hierarchy of Needs. The idea that before we can actually focus on true creativity, we always need to focus on, figure out the underlying layers first, the physiological, a sense of safety, love and belonging, self-esteem. And only when we have the lower layers in place can we truly sort of unlock capabilities. This model is generally useful in trying to look at any problem that we're trying to solve in terms of what the user actually needs to extract from the system before they can actually focus on creativity. We all know that when we build a product, there's a certain base set of functionality that needs to be available to meet their basic needs, right? The ease of experience, the ease of use, and only as we solve some of those underlying problems can they really open up. And we know that we've really sort of hit the mark in terms of sort of engineering any solution when all the basics are covered and they're really focusing on how they can really derive value from the system. The same is true of us, right? We need to have certain things taken care of in terms of meeting all of our needs before we can really open up and be truly creative and give everything that we want to provide. A better extrapolation of these things is actually a system that was come up with by Tony Robbins. It was derived by a bunch of other fundamental work. That said that all humans have 6 core needs: stability and control. We need a sense of stability in our lives. We need some variation in the system. We get bored if things are too stable, so we have to counter that with a little bit of instability. We need to have a sense of significance and esteem. We need to have love and connection. And in this model, this really says that there's these 4 things each of us have to have in our lives. If we don't have these, we will find some way to get them. In a lot of ways, significance and esteem and that need can cause people to do some pretty crazy things. If they don't have a sense of control in the system and they don't feel that they have significance in the system, they will do all kinds of crazy things in order to get it. Some of us have a tendency in engineering teams to really bed in on certain technologies and to say not knowledge share with other people because of the fact that we're significant because we have that knowledge and we don't want to share that with others. That's one way that comes out. Connection with team members. If we don't have that, we feel estranged from the team and we'll find some way to feel connected to the system, which can come out in sort of interesting ways. Stability, we all like stability. Understanding sort of how we do our work, how we get our work done. But at the same time, if we're just doing the same thing over and over and over, we get a little bit crazy, right? And so we need some variation in our work. But the last 2, growth and contribution, those are the sort of needs that really quantify our happiness. If we're not getting those, we don't have a tendency to feel happy and complete. And this comes back to that idea that we all have to be growing, right? Constantly learning new things, acquiring new skills, and then finding an outlet in order to contribute those back. This is always fun when somebody goes off to a conference, learns a bunch of new things, comes back, and then becomes a crazy maker who insists that we now need to like apply these technologies everywhere, right? It's always fun. So keeping those in mind is helpful as we build things. So growth. Like I said, learning is the primary skill any of us have in engineering. Things are constantly changing, like I said, even though the principles tend to be the slower moving element. So taking new technologies, taking new ideas, and then building them together in a way that is cohesive and adds to the system as a whole is a really important thing for us to do. I also love the Hebrew word for understanding is literally to build. Something all of us tend to love to do. That's why we're in engineering. We like to build things. We like to apply things that we learn. And this week is going to be the purest possible example of building in its purest, with every other concern taken away, all of your needs catered to, just build stuff and do amazing things. But understanding is always limited by constraints. In order to really, truly grow, we must challenge constraints. So, has anyone ever seen this before? This is what's historically known as the 9-dot problem. Has anyone done this? A couple people? All right. So this used to be a sort of mental puzzle that was given to people at parties and whatnot. And you draw the 9 dots, and you instruct them to connect the dots with no more than 4 straight lines without ever lifting your hand from the paper, right? Now, normally what you do is you would give this to somebody, you just draw the 9 dots and say, go ahead and solve it. And if they struggled, what you would do is you would then give them the hint. Think outside the box. If you've ever done this, that's the solution, or one of the solutions. And the key, of course, is that you can't do it unless you go outside of the box. The important lesson this teaches is that constraints are all around us, and we have a tendency to be constrained by what we perceive to be the edges of the system. So if you perceive that the system is the 9 dots, you never think of going outside, right? And in order to solve the problem, you must go outside. And this is the inherent nature of what innovation is all about, right? Innovation is a word, I think, that gets a little too pumped up in a lot of cases. We turn it into almost a religious concept. But really, it's just about creating something new, something that didn't exist in the world, whether it's a product or a process. It's some way that we approach things in a new way. And it inherently requires challenging constraints, looking beyond them. And this gets us to the idea of a paradigm shift. Paradigms, right, are a reality of the fact that there are certain things taken for granted as ways in which we operate. It must be done in this way. Once upon a time, CVS was the way that we stored our code. Does anybody use CVS? Because it was awful and it was terrible. But it was the way that you did it. And then Git came along. No one uses Git. Why would we use Git? That's crazy. Now, of course, if you don't use Git, you're insane. Same with GitHub, containerization. There are certain ideas that over time change and that we take those things for granted. And to innovate, we have to end up ultimately taking those ideas, throwing them away, and really challenging those constraints as to whether or not they really are constraints or they're the right constraints. And hopefully, this week, a bunch of you will get to actually challenge some constraints and think about doing things in a new way that can dramatically change the sort of boundaries and constraints of the systems that you have here at AppsFlyer. Nice reminder from, this is an old idea that was not originally Gandhi's, but Gandhi's is the best quote of it, right? First they ignore you, then they abuse you, then they crack down on you, and then you win. One of the reasons that I think innovation is particularly interesting here in Israel is that I don't know if any nation really appreciates innovation quite as much as y'all do. Right? Going so far as to sort of innovating and bringing back your own language. Nobody really can counter that one. So we want to give something new to the world that wasn't there before to make the world a better place by challenging constraints. And that's what we should be doing every day in our teams. But sometimes we lose our way and we stumble, right? And another great Hebrew word, tshuva. Sometimes we need to sort of go back and return to our roots. And the essence of doing anything particularly well is best expressed in the word Kavanagh, intention. Kavanagh is an important word to me because if you study anything, if you're a big reader and you read like a lot of self-help books and whatnot, you'll notice that there's an unfortunate and disturbing sort of trend you see across any book that's trying to tell you how to do anything better. And that is that they will always tell you that what you need to do is you need to be intentional. Just be intentional about it. I want to be better at hosting parties. Well, you need to really focus on throwing a great party, right? I want to be better at Go. What you need to really do is focus on being better with Go. All right, anything that you want to lose weight, right? What you really need to do is focus on losing weight. Whatever you got to do, it all comes down to Kavanagh, is having this intentionality about what it is that you're going to do. And then you just throw a couple of tips on top, and voila, you've got yourself a fantastic self-help book. So essentially, we're just going to do that. So focus. When the nature of intentionality really comes down to focus and putting our whole sort of hearts into what we're doing. And our brains naturally love to solve problems. That's what they do best. They don't tend to do repetitive actions very well, but they do have a tendency to really like to explore problems and to let ideas intermingle. It's the whole idea of a neural network and the way that our brains are constructed. This is also one of the reasons that given sufficient time and space, we can explore problem spaces in a really interesting way. It's why a lot of our best thinking tends to happen in the shower. There's absolutely minimal inputs into the system, and those ideas can really intermingle in your mind. Small and focused teams allow for sort of maximum innovation to occur because of the fact that you can really deeply focus with a number of individuals on a constrained problem set, which is what this week is all about. So hopefully this week you guys should be able to move the ball significantly further forward than you would in any other sort of time. And taking lessons learned from this week and why you know, hopefully as you work really well together with the team, hopefully you can take some of these learnings back to your teams next week and be able to apply them into your daily working routine so that you can stay even more engaged and more focused as a team. Constructive debate is a really critical part of this innovation, right? Because you have multiple individuals working together, that exchange of ideas pounding off of each other really moves the problem forward. And I don't know if there's any better example of this working really well than a yeshiva and the process that they use for learning there. And so what I wanted to go through now was a couple of different sort of techniques that can help you in organizing your work, things that will hopefully be useful to you this week as you get into teams to make sure you stay on task and stay focused on what you're trying to do. The first, I'm going to start at the bottom. I'm going to be systematic and just sort of work through all of them. So has anyone heard of GTD? Has anyone used GTD on a daily basis? You use it? GTD is a great system. It was created by David Allen. It's a really straightforward and easy method to use. It was created out of this idea that whenever you go on vacation, you have a tendency to get super organized before you go on vacation. I can attest to this because I did this on Thursday before I got on the plane to come here. It was fantastic. But the general process that you use is to sort of capture all the tasks that have your attention, anything in your head, anything and everything. Feed dog, commit local branch, get PR approved. Everything you sort of capture and put on paper, get it down so that you can work with it. Then you clarify what it is that you need to do on those things. What does it mean? What do you need to accomplish so that you can actually move the task forward? Then you organize all that into something that's sort of actionable and makes sense. Reflect on it and review it, and then you execute it. Just pound it out. One system that I really like in order to help make this work more effectively for people is called the Emergent Task Planner. This guy here, David Say, is a graphical designer who has a tendency to create a bunch of practical forms And this is a really handy tool that I tend to use with a number of my teams in order to stay focused. You can see here there's little bubbles where you can bubble in for each 15 minutes that you work on something, help keep you on task. It's a good way to keep projects moving forward. But particularly this week, a number of you will have problems that you want to explore and things that you want to build. But sometimes it can be difficult to determine how do we really focus on breaking down the idea into something that's actionable. Something that came out of the lean movement that gave way to agile and is now sort of prevalent throughout tech is this idea known as A3 thinking, which is really just scientific method applied to industry. And the idea that we use in A3 is that in order to solve a problem and explore it, what we do is we create a brief problem statement. What is it, the problem that we're trying to solve? And then we describe the current state. What is the state of the system as it exists today? And what is the future state of the system? What is the outcome that we want? What does the system look like when it's complete? And then we can actually do a gap analysis or a root cause as to try and figure out why the current system doesn't match the system that we desire. And from that, we can create a bunch of experiments. And those experiments we can dish out to team members to go and execute on and to do quick tests, right? Which is really just coming up with a hypothesis and then testing that hypothesis. We then look at the results that we got out of the system, and then we do something with those results, which is decide whether or not we're going to adopt the idea and move forward with it, or we're going to dump it. But when you sit down with your teams and you try to decompose a problem that you want to work on, this is a really good method of where are we at, where do we want to be, how do we change that, and let's do some experiments to actually iterate quickly towards it. Another method that I use is called SOPs, and it's a simple format of writing down processes. The purpose of writing down the process is really trying to take things that are in our heads and make them visual, decomposing any process down into its individual steps, along with sort of the prerequisites for how we solve that problem. Because once we actually have the process written out, it tends to be a lot easier to actually go and take action on it. This is one of the best ways around for actually automating a system. There are plenty of things that seem difficult or impossible to actually automate. Nobody's quite sure how to approach it. Once you can get the process down, you can share that knowledge, and then you simply make each of the steps in your process go away as you automate it down. So any of your projects that are related to taking some existing process where humans have to go do this, that, and the other thing, and turn it into a fully automated system, this is a really good way to approach that kind of work. And the last one is story mapping. Does anybody use story mapping? Is it a process that's popular here? Story mapping is great. Take a whole bunch of Postit notes, lay them out. What is the process? What does my user need to go through, right? They need to log into the system. They need to create an object. They need to manipulate an object. Then they need to get a report on it. Then they need to log out. What you do is you create a Postit note, lay it down as a backbone for sort of what the process is that you're going to go through. You can decompose those into major categories. And then we start to look at each of those parts of the process in isolation and start throwing down, Postit notes for, well, in order to do that, we need to go ahead and build this interface. We need to build that API. We need some place to store the user information, whatever. And we can start to break it down. And really all we're doing is we're creating a two-dimensional sort of matrix where we can lay out what our problems are and then decompose those problems into individual tasks or user stories, preferably. And then once you do that, then you can get all crazy and break it into time-boxed areas, right? So that tends to be a great way to approach problems where you need time constraint, which in the case of the Hackweek might be, say, 2-hour periods, right? You have 2 hours, go build this thing, get it done. And then you can move these things through using Kanban or whatever you want. But in general, one of the things that we found coming out of Lean is definitely true is that anytime we can take a process and make it visual and give it something we can see and manipulate, life tends to get a whole lot easier. So hopefully there will be 1 million Post-it notes sitting around for you guys to use this week. And hopefully you make good use of them in terms of decomposing work and dishing things out effectively to the teams, especially since I think that there's, if I recall, in the scoring and judging criteria, there's a real premium on people working together that haven't worked together before. So hopefully you guys can agree on methods that work well for you guys to collaborate. And so coming back around to sort of where I began with systems is always be approaching things with a system mentality, thinking about interconnections and emergent behavior in the systems that you're working on, and thinking about how those systems interact with other systems. When we think about the way that other systems interact with each other, that's when we get emergent properties that are sort of useful and instructive, right? We can never understand why a system is built the way it is when we only look at the components of the system. We only understand the purpose of the system when we look at how it interacts with others. I'll give you one quick example of something that's kind of interesting. Have you ever wondered why the Brits all drive on the wrong side of the road? I can say that because in this country you do drive on the right side of the road. If you look at a car or you look at even the modern day transportation system, you'll never understand why it is that Brits drive on the wrong side of the road. But the reality is that the car is part of the transportation system, and the transportation system has gone through a great number of iterations over time. Before we had cars, we had railroads. Before we had railroads, we had carts, right, behind being pulled by horses. And before that, we just had a lot of people sort of going back and forth on the road in horses. Because of the rules of chivalry and the fact that in England there were knights, if you were walking along the road, you had a tendency to want to make sure that if somebody came to, say, hijack you, that your sword arm was at the ready, so you could take a swipe at them. As such, Brits always stayed on the left side of the road whenever they were going along so that they could hack somebody's head off with their other hand. That design of the system perpetuated forward, right? Another fun thing about that is why are cars the width that they are, why are railroad cars the way that they are? Because that's how much space there is between two horses' asses, right? If you have a cart and you have two horses, you have the wheels following right behind the horses. All of our modern sort of transportation systems are actually based on the amount of distance between two horses' asses, right? When you look at a system and you look at all the systems that interconnect and all the permutations of that system, we can take attributes out of that system that help inform why the system is the way that it is. That's something we can never understand when we just look at individual components within that system. The reason the rest of us drive on the other side of the road is because that when we had cars come along, we had no such tradition, and it's a lot easier to shift a vehicle with your right hand. So we put the cars on the other side, made it a lot easier. Systems is an incredibly important way of looking at anything. But most importantly for us is that humans are a part of that system. This is like I said, this is the big thing I think is missing from most technology discussions, is we take humans out of the equation instead of putting them at the center, which is where they belong, both in engineering practices and the way that we interact with our customers. So, throw a little bit of love, have a little bit of intention. Thank you very much. I hope you have a great Hackweek.